Namaskaram. Welcome to Chindashala, a blended learning platform. In this series, we are going to discuss about the competency-based questions. The students, those who are preparing for board examination, CBSE, as well as JEE and NEET preparation, this series will help them to improve their grades and marks. The objective of competency-based questions in CBSE board exams is to assess a student's ability to apply their knowledge in real-world situations. These questions are designed to test a student's critical thinking skills, problem-solving abilities, understanding of concepts, reasoning skills, and analytical skills. We continue with grade 12 physics. Unit 1 Electrostatics. Question number 1. An isolated point charge particle produces an electric field E at a point 3 meters away from it. The distance of the point at which the electric field is E by 4 will be. The right option is option B, 6 meters. Let us see how did we arrive at this solution. As we know, electric field E is equal to KQ divided by R square. Since it is 3 meters away, so R is equal to 3, E is equal to KQ divided by 9. Given, we have to find out the electric field, the distance of the point at which the electric field is E by 4. So E is equal to E by 4. That is KQ divided by 9 into 4, KQ divided by 36. So KQ divided by R square is equal to KQ divided by 36. On comparison, R square is equal to 36, R is equal to 6. So B is the right option. Question number 2. Beams of electrons and protons move parallel to each other in the same direction. They The right option is repel each other. The explanation: electrons are negatively charged and protons are positively charged. Hence, the currents carried by them are in opposite direction. So, hence they will repel each other. So, option A, repel each other, is the right option. Let us go to question number 3. If the net electric flux through a closed surface is 0, then we can infer that the right option is B, no net charge is enclosed by the surface. The explanation: as per Gauss's law, the electric flux through a surface is proportional to the net charge enclosed by the surface. Hence, if the flux is 0, it means the total charge inside is also 0. So the option B, no net charge is enclosed by the surface, is the right option. Question number 4. A negatively charged object X is repelled by another charged object Y. However, an object Z is attracted to object Y. Which of the following is the most possibility for the object Z? The right option is neutral or negatively charged. The charge Z might be positive because it is attracted by the charge Y. Negatively charged objects attract neutral or positively charged objects. Any charged particle attracts neutral charge. As a result, Z might be either positive or negative. Question number 5. A cylinder of radius r and length L is placed in a uniform electric field E parallel to the cylinder axis. The total flux for the surface of the cylinder is given by. The right option is option D, 0. As per the question, flux through the curved surface is 0 as the electric field does not cross it. The flux through the flat surface face is also 0 as total incoming and outgoing flux is 0. So option D is the right answer. Question number 6. Which of the following diagrams correctly represents the electric field between two charged plates if a neutral conductor is placed in between the plates? The right option is option D. Electric field is always normal to the surface of the conductor. Question number 7. A square sheet of side A is lying parallel to xy plane at z is equal to A. The electric field in the given region E is equal to cz square k vector. The electric flux through the sheet is. Right option is A raised to the power 4 C. We know d phi is equal to cz square dx dy k vector. By integrating, phi is equal to cz square integral 0 to z dx integral 0 to z dy is equal to cz square. After integrating and applying limit, we get z multiplied by z is equal to cz square. Now it's given z is equal to a, so ca square. So the right option is b a, c a raised to 4. The right option is b a raised to 4 to the power a raised to 4 c. An electric dipole placed in a uniform electric field can experience. The right option always a force and a torque. In a uniform electric field, the forces on both the charges are not equal due to relative distances of the charges. Hence, the force does not cancel out. Similarly, the torque will also remain same due to the configuration of the charges. So, the right option is option B, always a force and a torque. Question number 9. Four objects W, X, Y, and Z, each with charge plus Q, are held fixed at 4 points of a square of side D as shown in the figure. Objects X and Z are on the midpoints of the sides of the square. The electrostatic force exerted by the object W on object X is F. Then the magnitude of the force exerted by object W on Z is. The right option is F divided by 5. Force on X, F is equal to 4k q square divided by d square. Now the d, distance between W and Z will be, you can make a right angle triangle WZ by drawing WZ. So WZ will be the diagonal. This side is D, this side is D by 2. Applying Pythagoras theorem, you will get D is equal to under root, the distance is equal to under root 5 D square by 4. Then the force on Z by WF dash is equal to 4KQ square divided by 5D square. On comparison, F dash is equal to F by 5. So the right option D, F by 5. And the last question in this series. A square surface of side L meter is in the plane of a paper. E is emitted only to the lower half of the square surface as shown in the figure. Electric field E is volt per meter. Electric flux in SI units associated with the surface is given by, right option is 0. We know electric flux phi E is equal to integral E dot ds, E ds cos theta. The angle between these two is equal to 90 degree. So ds and electric field is equal to 90 degrees. So EDS cos 90 is equal to 0 as cos 90 is equal to 0. The lines are parallel to the surface. So option B is the right option. We'll be soon with the next questions based on competency based questions from the same unit very soon. Keep watching Chintashala. Keep learning. All the best. Thank you.